2, Lesson 8, Comparing Relationships with Equations. I can decide if a relationship represented by an equation is proportional or not. So we have a notice and wonder. Do you see the pattern? If so, what is it? So it looks like it doubles both ways. So, and then it tripled so it looks like it's gonna double the length and width, then triple. Not triple, triple. So what predictions would you make about the future rectangles in the set? So I would do, my length would be 3 times 3 to the first power. No. I would say 3 times 3 times 1, and then this number would just keep going up depending on which one it was. So for this one it would be 3 times 3 times 1, 3 times 3 times 2, 3 times 3 times 3. So my width would be 1 times 2 I don't know, plus 1. Because the width would be multiplied, and then you would have to add something, so it wouldn't necessarily be a multiple on the width, it would be an addition, right? Because it's the second one plus 1, and then it would be the third plus 1, the fourth plus 1. Okay. So then it says more conversions. Use the equation 9/5 Celsius plus 32, where F represents degrees in Fahrenheit and C represents degrees Celsius, to complete the table. So that means I'm going to plug in these numbers in for Celsius. So is this a proportional relationship or not? So I just want to go back to, you're using your handy dandy calculator. So if you're using your cell phone, which is what I'm using, I'm going to do 9 divided by 5 first, and I get 1.8. So now I'm going to do 1.8 times 20 plus 32. I get 68. So then I'm going to do 1.8 times 4 plus 32. $39.2. So then I'm going to do 1.8 times, not 4 again, times 1.75. Not 1.75, 175 plus 32. I get 347 degrees. That's hot, hot, hot. Is this a proportional relationship? Why or why not? No. It's not going to be a proportional relationship, because each time it's not the same degrees per hour. degrees Fahrenheit. So it does not determine a proportional relationship because the number of degrees per Celsius is not the same. So the number of degrees per degree Celsius is not the same. As soon as I saw this plus 32, I knew it was not going to be a proportional relationship because it's not the same constant of proportionality. So use the equation C equals 2.54n, where C represents the length in centimeters and n represents the length in inches. So I've got 2.54 times 10. That gives me 25.4 centimeters. 2.54 times 8. So I use my calculator. 2.54 times 8. And I get 20.32. Then I have 3.5, so that's really 3.5 for the purposes of my calculator. 2.54 times 3.5, and I get 8.89. So is this a proportional relationship? Yes. The number of inches times 2.54 always equals the number of centimeters. So it's really important to recognize that no matter what I do, it's always going to be the same. My constant of proportionality is going to stay the same. There's nothing extra. So then it says, predict which of these equations will represent a proportional relationship and those that will not. So let's try it. So based on the fact that when I add, it doesn't work, I'm going to put that there. When I multiply, it does. When I divide, it does. So exponents, I've got to think about that one because exponents are going to be a little bit different, right? Because as they get larger, I have to think, okay, does that make sense that each time it's going to work out? I'm not sure, so I'm going to say they will. And let's see what happens. So now it says complete the table using the equation to represent the relationship. So Ian does these all the time. So 4 plus 2 is 6. 4 plus 3 is 7. 4 plus 4 is 8. 4 plus 5 is 9. So then I have to see if they're going to be equal. So 6 divided by 2 is 3. 7 divided by 3 is going to be 3.5, I think. No, 2.3. All right, 8 divided by 4 is going to be 2. 9 divided by 5 is going to be 1.8. So is that proportional? No. This keeps changing. So now let's check the next one. So 4 times 2 is 8. 3 times 4 is 12. 4 times 4 is 16. 5 times 4 is 20. So now 8 divided by 2 is 4. 12 divided by 3 is 4. 16 divided by 4 is 4. And 20 divided by 4 is 4. So this would be a yes. So let's check the next one. So 4 divided by 2 is 2. 4 divided by 3 is 1.3 repeating. 4 divided by 4 is 1, and 4 divided by 5 is 0.8. So now I have to test it. So 2 divided by 2 is going to be 1. This is going to be 3 divided by 1.3 repeating. It's going to be 2.25. 1 divided by 4 is going to be 0.25. And 8/10 divided by 5 is going to be 0.16. So this is not true. So let's try the next one. So 2 divided by 4 is going to be 1/2. 3 divided by 4 is going to be 3/4. 4 divided by 4 is going to be 1 whole. 5 divided by 4 is going to be 1 1/4. So now I have to test it to see if it works. So 0.5 divided by 2 . 0.75 divided by 3. So when x is on top, it works out. So that's interesting to know. Okay, so 4 squared is going to be 16. 4 to the third power is going to be 64. 4 to the fourth power is 4 times 4 times 4 times 4. 256. To the fifth power, it's going to be 1024. Now if I divide it, that's going to be 8. 64 divided by 3 is going to be 21 1/3. $256 divided 4 is going to be 64. And then 1024 divided by 5 is going to be 204.8. So this is a no. So I wonder if this is going to be a yes because of where the x is. Let's see. So 2 to the fourth power is going to be 2 times 2 is 4. 4 times 2 is 8. So it's going to be 16. 3 to the fourth power is going to be 3 times 3 times 3 times 3. It's going to be 81. And then 4 times 4 times 4 times 4. 256. And then 5 times 5 times 5 times 5. 625. So then if I'm going to test it, I get 8. I don't think this one's going to work. 27, 64, 125. So this is also a no. So it says drag and drop. So I know this was not. When the x was on top, it was. When the x was on the bottom, it wasn't. I was right about the addition. That was not. That was. Okay, so what do the equations of the proportional relationship have in common? Well, if you look at it, the constant of proportionality is the reciprocal, right? 4 and 1/4 are reciprocals. So, let me clean that up. So the constant of proportionality are reciprocals. So when you looked at these, they were exponents. Exponents don't work at all. When it's not the reciprocal, it doesn't work. And when you're adding, it doesn't work. So now decide whether or not each equation represents a proportional relationship. Well, I see a minus x. That's out. I see a straight up multiplication. B is in. I see where you're dividing by the same amount. C is in. I see an exponent. D is out. It's just that simple. You're just looking through it and seeing what you see. There's your cool down. You're doing another deciding if they're proportional relationships or not.